So let's say that we wanted to simplify this here. So notice that what I'm doing here is I don't want to divide, I want to multiply these fractions. So I turn from division to multiplication. The first stays the same, but this one gets flipped or reciprocated. Now look at each of the four pockets and simplify if possible. For instance, up here, I see that I can take out a 3. So I'm going to remove a 3 here from everything there. And then let's see, down here, the greatest common factor there would be x squared. So look for greatest common factors everywhere. Here, the greatest common factor would be 4. I'd be left with 2x squared plus x minus 3. And then down here below, I can take out a single x, and I'm left with these pieces. Now, continue this factorization process. Think of what else can be factorized. For instance, that's just a 3. However, this here, if you go back to earlier levels of math, that becomes like x minus 7 times x plus 2, right? That looks good. And then that just stays the same here beneath it. Now, what about up here? That stays a 4. And I have a feeling that this can be factorized, and it can. If you experiment with these numbers, I believe this is what you'll get. Let's make this positive and let's make this negative. So tweak the numbers until they work, until the expansion of this gives you back that there, which this does. That x stays out there. And then in here, that factorization would be x minus 7 times x minus 1. So from division to multiplication, GCFs, further factorizations, and then comes the fun part when things go away. For instance, x minus 7 knocks out x minus 7. And x minus 1 knocks out x minus 1. Does anything, ooh, look, that knocks this out. Satisfying. So what's left? I think that's all that goes away. So in the numerator, we have a 3 times a 4, which is a 12, along with this extra random piece. In the bottom, these guys give you x cubed. There's nothing else that can be cleaned up. Final answer.